Hi, everyone. Welcome to the Physicists To-Go communication training. We're going to share some best practices for communicating with younger audiences, as well as go through a customizable slide deck that you can use for your presentation. I'm Nicole Schrody, Public Engagement Program Manager here at APS.
Hi everyone, my name is Midhat Farouk. I am a Senior Careers Program Manager at APS.
Great. And while you are doing your virtual visit, you will be a representative of APS. So we go by the code of conduct, which you can see here. This is the same code of conduct we use for meetings. If you would like to pause the presentation and take a closer look, please feel free. If not, there is a link down to our code of conduct at the bottom. The goals and objectives of this visit are for you to communicate your emotional interest that you have for physical science. The students that you'll be talking to in middle school and high school are just starting in their STEM journeys, and they really like to connect to the human aspect of what you're doing as much as the content. We hope that you open students' eyes to how impactful physics is and how it affects their daily lives. And you can relate that to the work that you do. Discuss problems that aren't solved yet. While you're talking about problems that you try to work to solve, you can inspire students to talk about problems that aren't solved, and maybe they can be the ones in the next generation to do so. Encourage students to start exploring. And then also, as you're going through this, think about your goals and objectives as you plan your visit. And most importantly, have fun. So when you're getting to know your audience, you all should have received an email detailing your matched instructor. And it is your responsibility as the scientist to reach out first. If you don't hear back from your matched educator, please email public-engagement at aps.org. You'll find this in your matched email as well. As you're talking for the first time with your matched educator, think about asking about the demographics of the class. What age are they? Are they all seventh graders? Is it an honors class? Is it a class with a high amount of students with special needs? Things like that will really help you to guide your presentation. Talk about any disability, gender, or language consideration for anyone involved. How would you like the students to address you? By your first name, with your honorific of doctor? Just letting people know beforehand is a good idea. You should speak to the teacher about what they learned right before your visit and what they'll be learning after, so you can frame your content. How much time will you have for presentation, for Q&A, things like that. And then it's important for you to really co-create and edit the slides with your matched educator so that you're sure that you're using the same vocabulary and terminology that they use in class. We don't want to confuse students, but really help elucidate some of the ideas they're learning in class. And make sure you're discussing the host teacher's goals, right? So take yours into consideration as well as the host teacher's to make sure that you're both getting out of the visit what you would like. When you're connecting with students, really value their ideas and expertise. They come with different expertise than we do, and we should value everyone's contributions. With this, avoiding savior mentality, we're not here to fix who the student is or their interests. And, try not to frame yourself as the giver of knowledge. We do obviously know more than these students because we're older and we've been studying this stuff extensively, but they're not missing anything, and they have access to it if they follow along with the same goals and objectives that we do. Be open to learning and asking questions of the students. On that topic, students might ask unrelated questions, and it might seem kind of out of left field to us, but this is how they integrate what we're saying to their worldview. For instance, let's say you work in Huntsville and a student asks the question, what's the weather like in Alabama? To you, this might seem out of left field, but for the student, it might really be helping them place you in a certain place and kind of connect with the work that you do. So just try and answer all questions with the same regard that you would a content question. Student views on the topic you're presenting may not change in the 45 minutes or so that you are presenting, but this exposure is setting a seed, and maybe they'll reflect back on it in a year or two and make new connections. So be okay with that. Be mindful that all students have different resources and backgrounds and preparation levels, and we can't assume what students do or do have based on any sort of view of them that we have. So these differences aren't always visible or obvious, and don't assume if a student has an identity that they either have or lack any resources. I always like to use we, like today, we are going to explore magnetism. It really encourages inclusion. Here's an example of what I was just saying. Sprinkle questions throughout the presentation, asking students, what do you think? Why do you think that? Have you experienced something like this before? Always leaving wait time after you answer a question. You don't always have to call on the first kid that raises their hand. Some people need a little more time to formulate answers. And encourage students to interact during the presentation. Maybe you have a simulation that you want them to take a look at. You can talk with the educator about the resources they have for those kinds of things. I like to give people whiteboards so they can kind of write out their answers and show them to you. It helps people who don't like to speak out loud to be engaged. Also, having students talk to each other with their partner before answering, it gives them the opportunity to speak about the group's ideas instead of just their own. It's a little safer sometimes. And one of our participants in Physicists To-Go suggested having the students come up to the computer screen and give their name when they're asking questions. And that way you can interact with them a little bit better instead of them sitting in the back of the room. These are all great tips for when you do the Q&A sessions, which you'll see in your customizable slides. General tips for communicating with the public. Storytelling in science communication. A lot of us as scientists don't see this as the best way to communicate, but research has shown that this is a better way to connect with non-expert audiences, to give them information about your science or research. Narratives are easier to comprehend for audiences that aren't as well versed in what we're saying, as well as anecdotes and analogies. Please use as many of these as you would like. And stories have a beginning, a middle, and an end. So make sure to include this. And we've kind of modeled this for you in the slides. But, students want to know, what were you like in middle school? How did you get to where you are? Not just, I work in this lab right now, I did this college. Like, how did you get there? The story really helps people connect. Avoid jargon with your students. Again, talk with the teacher about the words they use to describe the phenomenon you'll be talking about. Here are some, you'll get links to this, but here are some glossary terms that are considered jargon in physics. Mathematical terms students might not have been exposed to before. I like to define a word before I use it. An example, I study what happens when light waves meet. This is called wave interference. If you say the definition first, people feel like they can connect. Sometimes if students hear a quote unquote hard word, they immediately say, oh, I don't understand. And then they don't actually realize that the definition is within their grasp. Diagrams are always helpful. I like to talk about the Latin root of words and see if you can connect the English or Spanish or other languages to it to help them understand. And always err on the side of caution. You know, define as many words as you can. It'll never hurt. And, you know, next tip is just to practice. Maybe find someone about the same age as your students or record yourself doing the presentation, and it'll give you an idea of what you sound like. Great. And we're so excited to hear about how these go. And I'm going to pass it over to Midhat, who is going to show you and take you through the customizable slides that we'll provide.
Okay, thank you, Nicole. So I'm just going to go over some of the customizable slides that we have provided for you to make your own before presenting to your classrooms. So as Nicole said, it's really important to form this connection with students and tell your story. So we recommend starting with your story. We have linked some storytelling techniques for you to use if you like. But yeah, starting with who you are, what sparked your initial interest in the field? So what first got you interested in physics or STEM, how that interest developed, and maybe when was the first time that you got really excited about physics or the specific topic you're there to present. So whether that's wave mechanics or optics, what got you excited about that for the first time ever? As you can see, there are some highlighted parts in the slides. So this yellow highlight means this is a place where you can customize and add whatever you would like to add and you would like the students to know. So talking about your interest in physics and STEM, and then connecting to them at their age. So maybe describe what you were like when you were in high school or middle school, some of your hobbies, interests, passions, maybe clubs or camps that you attended that led you to your interest in STEM. And you get bonus points for adding pictures of you at that age. Just continuing that story. So now you've talked about your interest in physics, how you got started in STEM. Now you can talk a little bit more about your current job, your place of work, maybe add some pictures of your workplace so the students can make that connection. And then we recommend talking about some pitfalls and missteps that you've encountered along the way. If you're comfortable talking about this, of course, it's really important for the students to know that it's okay to make mistakes. They won't necessarily have one linear path into any career. So it's okay to have some pitfalls. It's okay for people to change their mind about their career path. It's okay to, you know, kind of go in a zigzag way to get to where you are. And then moving into what problem your work aims to solve. So sort of zooming out of your research or your day-to-day work and talking about the big picture to help them understand how it relates to physics or how it relates to the real world. Maybe describe times in your job where you get to think outside the box and be creative to get them excited about this type of work. And how your job connects, if possible, with the content that you're there to discuss, the specific topic that the teachers invited you to talk about. So now connecting it to the topic of interest, of course, these are slides that you will need to develop yourself, but we do recommend, if possible, to ask students their definition of the topic. So, you know, what do you think of when you think of optics? You know, what are some words you use to describe a wave or how light reflects off the mirror, right? And that way, not only are you getting them to participate early on, you already have an interactive audience, right? By asking them some questions, but also you're getting a sense of what their knowledge is and what words they're using, because then you can use those words back to keep them engaged and connected throughout your presentation. If you do end up doing this before the classroom visit, so definitely do this during the visit, but if you happen to ask the teacher about some of the jargon that the students are using, maybe you can find a short video clip that uses similar words, or, you know, just a fun interactive thing that you can present to them that will resonate with the students. This is optional, of course. Next, of course, you will move into the content that you're there to present. We haven't provided these slides because this will depend a lot on the specific teacher and the specific content, the specific topic that you're there to present. So we've left this slide open. You can have multiple slides, of course, and we recommend referencing this communication training and all of the great tips that Nicole just went over. Just keep those in mind as you develop this material. Here we recommend pausing. This is optional, but we recommend having a Q&A section because you've just, talked a lot about your own career path, your own story. You've talked a lot about the specific topic you're there to present. So students might have a lot of questions at this point. So just pausing for a second, saying, okay, any questions so far? Once you've done that, you can move on to more content. So of course, we've asked you to present your own career path, but we want to make sure that these students know that there are many different career paths possible with a physics degree. So we recommend adding some more information on different types of career paths. You're welcome to add your own friends or people in your network and highlight, what those career paths are, how those people use physics in their work, what problems they're trying to solve. But if you would like some examples, we've included these in the slides. So at this point is where the middle school slides stop. This is a great place for them to kind of digest the material and then start asking you questions. We're going to a high school classroom. We have a few additional slides with data in them that we think is more appropriate and relevant for the high school level. So some of this data, you've shown them so far, you've talked about your own career and you've sort of highlighted a few other career paths, right? But some of these high school students might be thinking, okay, but what roles are out there? What does this mean? What types of jobs are out there, right? What are all the different types of jobs? So here are some resources from the American Institute of Physics. Their Statistical Research Center has lots of great data on their website. So this is from a survey of physics bachelors from classes of 2017 and 2018. And it's some of the most common job titles that these physics bachelors had after graduating. So what I recommend doing with this slide is sort of, putting it up, letting them digest it for a few seconds, and then maybe calling out a few of these titles that may interest your audience or maybe things that interest you. So if I'm presenting, I might say something like, there are lots of different jobs out there with a physics bachelor's degree. For example, you can have different types of engineering roles like optical engineer or research engineer, or you can do quality testing, right? You can even go into computer hardware and software roles, like go into IT, go into programming, data analysis, data science. You can go into the business or finance sector. You can do research work, and you can do a lot of different types of education jobs. Feel free to call out whichever of these makes sense to you and you think might be interesting for your audience. Then, of course, I think it helps even more to make careers more concrete in the students' heads, as opposed to sort of this abstract thing that might exist, to give them actual company names that they've heard of that hire physics bachelors. Again, this is from AIP. They're wonderful data. So some of the companies are big tech like Apple, Facebook, Google, right? They've heard of these. Other tech companies like AT&T, ExxonMobil, IBM, Intel, and then they can go work at government labs. They can go work for government defense contractors. These are some that Nicole and I picked out from the AIP website. There's actually a much longer list on the website, and we've linked that at the bottom of the slide there for you or the students to review. Also, you can add your own institution. If you all hire physics bachelors, feel free to add your own institution for them to see. You can say, hey, you could come work with me. And then I think this is the one of the last data slides. So, just making that career path a little bit more concrete. What does the day-to-day work look like? we have the slide on knowledge and skills used by new physics bachelors. So again, let them kind of absorb the slide and then call out whatever interests you. So did you know with a physics bachelor's degree, when you go out and work in engineering or computer science, you will get to work you will most likely work on teams. You will still be solving technical problems. You'll be doing some you might be using some specialized knowledge, and you'll be working on, you might get to use programming, you might manage projects, right? Whatever speaks to you, whatever might speak to your audience. And then lastly, a slide on salaries, because I think students these days are thinking about things like this a lot more than at least I was when I was in high school. So this is just an overview of starting salaries for new physics bachelors from 2019 and 2020. So please emphasize that these are starting salaries. So this is where they would start and then they would move up, right? And these are broken down by different sectors that you can talk to them about as well. And then we recommend having another question and answer session. They might have questions about some of this data. They might have questions from earlier that they didn't get a chance to ask. So just to close out, again, we want this session to be interactive. We want the class to be engaged. So giving them another chance to ask questions would be great. And then lastly, we recommend closing things out with a student reflection. So asking them, what did you discover about yourself during this presentation? And what is one thing that you learned about science and technology from this presentation? So having students think about this there and then will help them, figure out what some of their takeaways were, and will also help them will help those takeaways stay with them longer. So you can do this. You can give them a couple minutes to reflect to themselves, and then use whatever you like. If you want them to share answers out loud, or if you want to use a poll, or if you want to use a Jamboard, some kind of interactive activity, it's up to you. So those were the slides. We hope you find them helpful. And Nicole's going to tell you where you can find these slides.
Thanks, Midhat. So here you can find the high school presentation and the middle school presentation, depending on the age of your assigned classroom. You can type in this tiny URL. The links are also in the caption for this YouTube video. You can use this QR code for both. Make sure you make your own copy so that you can edit the yellow parts and put in your own information. So feel free to pause this and write these down or find these now. And then lastly, we really appreciate your participation. We know that the students and the educators will get so much out of this. We will send a feedback survey later in the year, and we would love your feedback. And if you have any questions at all, please email public-engagement@aps.org. Thank you so much.